Alrighty, in this video we are going to be talking about exponential integration and how to go about this. Once again, for this video, we are going to be using U substitution, but remember that U substitution is just going to be a game of guessing and checking on what your U is. Obviously, for number 4, even though I've told you guys maybe use your denominator as U, this isn't going to help us in terms of this term right here, because then du is going to be 2x, which is not what we want. Instead, if you have e to the something, probably do that first. So your something is going to be 1 over x. So u is equal to 1 over x, which means that du, and remember that this is the same thing as x to the negative 1, du is going to be negative 1 x to the negative 2, which is negative 1 over x squared dx. All right, so that is du, and u is 1 over x. Well, if I were to take the reciprocal of this is just going to be negative x squared, which then cancels out with this in the denominator. That's good. That means I'm only left with a negative on the outside, and then I have e to the u du. Since this is an indefinite integral, I don't have to change my bounds because guess what? I don't have any bounds. So here I'm just going to take the antiderivative of e to the u, which is just e to the u. So I'm going to get e to the u plus c. And then, of course, we know that u is 1 over x, so I have negative e to the 1 over x plus c as my antiderivative, which I'm going to label as big F of x. All right, same thing for number 5. You'll notice that with number 5, you have x's as your you have x's as your exponents. Since you have x's as your exponents, and that's not really a function inside of a function, then you should probably look at, let's say, your denominator again and see if this can be u. So let's say that u is e to the x plus e to the negative x. Then du is going to be e to the x minus e to the negative x. Notice I have minus e to the negative x because if I were to use the chain rule here, the derivative of negative x is negative 1, which is this right here. Which works out for us because the reciprocal of this is going to be 1 over e to the x minus e to the negative x, which will cancel with this. Because I could take out a 2, and I'm left with this right here. All right, so if I have u to be e to the x plus e to the negative x, which is your denominator, and I have dx being du over this lovely thing right here, this will cancel out with this, that's gone. This right here becomes u right here. So now I have 2, my coefficient that I brought out, and then 1 over u squared du. Once again, since this is an indefinite integral, I'm not going to change my bounds because guess what? There aren't any. All right, so now what we're going to do is just take the antiderivative of u to the negative 2 du. You're going to up your power. So that's going to give us u to the negative 1. And then we're going to divide. Well, if we divide that by 2 here and negative 1, that's just going to give me negative 2 and then plus c. Then, if I know that u is e to the x plus e to the negative x, I'm going to get my antiderivative to be negative 2 e to the x plus e to the negative x, the negative 1 plus c. Or if I were to make this prettier, I'm going to get negative 2 e to the x plus e to the negative x plus c. All right, for number 6, we want to find the particular solution that satisfies f double prime of sine x plus e to the 2x. And we have that f prime of 0 is 1/2 and f of 0 is 1/4. So the first thing that we're going to do is take the antiderivative of f double prime of x to get f prime of x. The antiderivative of sine is going to be negative cosine. And then e to the 2x, you're going to use its simple chain rule. And hopefully by now you'll notice some patterns with the exponential functions here. Since your exponential is 2x, then obviously you want to have a 1/2 somewhere so that your coefficient is a 1 right here. So that's what I did there. Divide that by the reciprocal, aka 1/2, or multiply by the reciprocal. And then, of course, you need a plus c. You are going to solve for c given that f prime of 0 is 1/2. So you know that this is going to be 1/2. And then you have negative cosine of 0 plus 1/2 e to the 2 times 0 plus c. Now, if I were to think about cosine of 0, remember that cosine is right here, and that's going to be 1, 0. So cosine of 0 is 1, but I have a negative, so this is negative 1. Plus e to the 0, which is just going to be 1. So I now have 1/2 plus c is equal to 1/2. The 1/2s will eventually cancel out with each other. So now I have 0 is equal to negative 1 plus c, or c is equal to 1. So this means that my c value here to satisfy this part is 1. So now I have that lovely thing plus 1. And then if I were to take the antiderivative of that again, the antiderivative of negative cosine is going to be negative sine. And then the antiderivative of 1/2 e to the 2x is going to be 1/4 e to the 2x plus c. Now, if f of 0 is equal to 1/4, aka this condition right here, I'm going to substitute in 0. You'll notice that sine of 0 is going to be 0, and then you have 1/4 plus 0. So you have 1/4 is equal to 0 plus 1/4 plus 0 plus c, which means, plot twist, c is going to be 0. So if c is going to be 0, then your final answer is going to be f of x is equal to negative sine of x plus 1/4 e to the 2x plus x. All right, number 11, you want to take the integral of 2 to the x. Now, as a reminder, this is one of the integration rules that I told you about. So that's going to be this rule right here. So this is not saying find the derivative. This is saying take the antiderivative. So we are going to have my base being 2, and then my exponent being an x. So I'm going to have 1 over ln of whatever your base is. So that's going to be 2 times 2 to the x plus whatever your c value is. So that's going to be my antiderivative. All right, for number 12, this kind of looks like what we have up here, except we have a function inside of a function. So it's going to be very similar to 11, except guess what? I have a sine of x. So we're going to use u substitution and say, let sine be u, so that du is cosine of x dx. Now, if that happens, remember that if I were to take the reciprocal of this, the cosines will eventually cancel out. So now I'm just left with the integral of 3 to the u du. And then if I were to take the antiderivative of that, I'm going to get 1 over ln of 3 times 3 to the u plus c. We know that u is sine of x, so I have my antiderivative being 1 over ln of 3 times 3 to the sine of x plus c. Same thing with number 13. So what I want you guys to do for number 13 is to pause the video, try it on your own, and then come back. Now, 13 might be a little bit tricky because you have this as an exponent. So you're going to set that as u. So then du is going to be 2 times 3 minus x dx. And that's okay that we have a 2 as a coefficient, because if we take the reciprocal of that, that's just going to be my coefficient. So now I'm going to have 1/2 the integral of 7 to the power of u du, because your 3 minus x and your 3 minus x right here will eventually cancel out. We are going to take the antiderivative of 7 to the u power. So that's just going to be 1 over ln of 7 times 7 to the u plus c. I'm going to get 1 over 2 ln of 7, 7 to the u plus c. We know that u is 3 minus x to the second power. So using that substitution again, I have 7, 3 minus x to the second power over 2 ln of 7 plus c. Just like what I said in the first video on day 1, don't be surprised if you don't see a 2 and you see a 49 up here, because 7 squares 49. So make sure that you are confident and comfortable with taking properties of logs, in this case using the power rule, just in case on the multiple choice you don't see something like this, but you see ln of 49. All right, for number 14, I want you to pause the video again. Try to do this on your own. This one shouldn't be too bad. It's a definite integral from 1 to e. So just, try it and see if you can do it. Now, for number 14, I'm going to break this up into 2 parts. And we kind of already figured out the integral of 2 to the x, which we kind of found right here. 1 over ln of 2 times 2 to the x. Which, honestly, you're going to do the same thing for 6 to the x anyways. So I have 1 over ln of 6, 6 to the x, from 1 to e. And then you have 1 over ln of 2, 2 to the x, from 1 to e. So now I have 1 over ln of 6 times 6 to the e. And I'm just going to put that up top so that it looks prettier. Minus 6 over ln of 6 okay, and then I have my 2 to the x. So now I have 2 to the e ln of 2 minus 2 to the 1 over ln of 2. Now, if you wanted to make this prettier, you can. So I have 6 to the e minus 6 ln of 6 minus 2 to the e minus 2 over ln of 2. That's your final answer for your definite integral.
When it stops talking, I'll translate.
Okay, one more. 15, I have 3 to the 2x over 1 plus 3 to the 2x. I have a 3 to the 2x right here, and I have a 1 plus 3 to the 2x right here. So thinking about that, we should probably let u be, guess what? 1 plus 3 to the 2x. So that du is equal to 3 to the 2x times ln of 3 times 2. And then dx. Now, here's the thing. The 3 to the 2x and the 3 to the 2x will cancel out. So the only thing that doesn't really cancel out is going to be your ln of 3 and your 2. So now you have 1 over 2 ln of 3. And then you have the integral of 1 over u du. All right, so once we do that, we have 1 over 2 ln of 3. The antiderivative of 1 over u is ln of the absolute value of u plus c. We have u to be 1 plus 3 to the 2x, so I have 1 over ln of 8. Figure out why that's 8, hint, hint. And then ln of 1 plus 3 to the 2x plus c. And that's going to be your antiderivative. All right, in class, whenever we are in class, we are going to be doing more applications of this in terms of, let's say, Unit 3. So maximums, minimums, horizontal tangent lines, all of those applications that aren't really find the derivative or find the antiderivative and call it a day. Because on your quiz, it's going to be more application based.